Okay, so let's talk a little bit about ggplot. Ggplot is widely considered, even by people who are not huge fans of R, to be one of the best packages and one of the best systems for data visualization in any statistical programming language. So it's definitely fun to use. You can do everything from creating initial exploratory plots that are kind of ugly but really informative, all the way up to creating like production ready, publication ready, beautiful plots with custom colors and all of that. We're not going to go all the way to the custom colors today. I just want to give you like the basics of ggplot, and then it's something that you can always build on once you have the basic understanding for how it works. So ggplot was created based on the layered grammar of graphics. And this is the idea that you can perfectly describe any sort of data visualization using basically a grammar, like you would in language. You'd be able to like perfectly specify what the elements of the visualization are. So for ggplot, the first layer is the data. So the first thing that you need in a ggplot call is always the data. And you'll see, okay, so if I just give ggplot the data, it doesn't know what to do with it. It knows that I want to make a plot and that the data that I'm using for it is SPR complete, which is what we just made with the joining in the previous section. But it doesn't know what to do with that at all. So then you need layer 2, and layer 2 is the aesthetic mappings. So here you need to tell ggplot how the information from your data frame should be matched to the graphics. So which columns are going to be used, how are they going to be used, where, which should they be mapped to? So what's going to be on the x-axis, what's going to be on the y-axis. So we need to add the aesthetic mapping with AES. And you'll see in ggplot, we use a plus sign. So it's not a pipe, it's actually a plus sign, and it has to come on the line above. So, I mean, it could also be, you could have it on one line like this. That would be kind of not necessarily traditional. It's more traditional to see it on multiple lines, but the plus has to come in the line above. Okay, so let's tell this ggplot that we want to put the condition on the x-axis. So as soon as we do that, we can see that ggplot is getting ready for us to make a plot, and it knows that on the x-axis we have condition, which has two categories, match and mismatch. So it's already ready to make a plot, but we need to tell it what type of plot we want to make, and that's layer 3. So layer 3 is the geom, so the geometric shape that the graph should have. And so this could be like a bar chart or a line graph or a scatter plot. There's tons of options for what kind of geom you want to add, and that would be layer 3. So layer 1 is the data, layer 2 is how we map the info from the data frame onto the graph, and layer 3 is what kind of graph we want to make. So if we do a bar chart here, then ggplot will automatically know that a bar plot needs to count, and it will count up how many items are in our match condition and how many are in our mismatch condition. Okay, so there's a couple of, I'm going to show you just a bunch of different geoms, but remember that the basic idea is like layer 1 is data, layer 2 is aesthetic mapping. So how does the data frame get mapped onto the plot? And number 3 is the geom. So if you have a categorical variable, then you're going to do, like I just showed you, a bar plot, or you could do a bar plot. So this only requires one variable. So if we do a bar plot of education, it will just show us how many, this is actually showing us how many rows are in each education bin. And it only needs one variable, but it doesn't matter if you put it on X or Y, that's just gonna change how it looks. But all it needs is one. So that's geom underscore bar. If you have just one variable, but that variable is not categorical, it's numeric, then you might want to use a histogram. So histogram will show you where the data is located. So are there more low values or are there more high values? So we do layer 1 data, layer 2 aesthetic mapping. Here we're going to have just one variable, which is numeric. So let's look at the response times. And it's geom_histogram. So you can see that makes a histogram that shows us, that a lot of the data is here between 0 and 500, but we have a bit of a tail going up towards longer response times. So that just shows you how your data is distributed. You have one numeric variable. And here you can see it tells us that it used 30 bins. So that means that it's cutting our data into 30 equally sized groups and then showing how that's distributed. But you can change that as you want. So you can do like, bins is 50, and then you'd get like smaller groupings of the data. You could make this number really whatever you want to get an idea for how your data looks and how the spread is. And a really similar plot is the density plot, and this just takes your histogram and kind of draws a line over it to show what the basic shape is. So you have data, again, then aesthetic mappings, and then geom density, and you'll get this line. That's useful if your data set is really big, but in most cases with medium-large data sets, histogram is probably going to be a better call there because you're going to lose a little bit of information here. Okay, so those are the basic one variable charts. So there's the counted bar chart and then the histogram and the density plot. If you have two variables, you might want to do like a scatter plot, which is going to put a dot on each point. And that would be for two like continuous numeric variables. I didn't have a super good example of that in this SPR data set, so I just did word length by frequency. And I've done something kind of fancy here, which is that I log transform the frequency within the ggplot call. So it's instead of just using frequency, I took the log transformation, which is something that you would often look at in like self-paced reading data. You often like log transform the frequency. If that's not your area, don't worry about it. I just want to show this geom_point. And you'll see it puts a dot on each point. Like I said, this isn't the best example because we only, we don't have words that are like 3.5 letters long. So that's why you're seeing like these gaps in between of the numbers. So it's not the best example, but just so you can see what a scatter plot looks like in ggplot. So again, that's geom point. Something similar is, or for a similar type of data would be just like a line graph. You can do that with geom smooth. So just always remember that the first layer is data, the second layer is the aesthetic mappings. Here we have two, and geom smooth is our geom. That will make like a smooth line that just follows where the points are. And all of these geoms have a couple of extra options that you can always like look up in the documentation, or you might see when you're looking for answers online or something. So this one, for example, has method LM, and that will make like a linear model. It stands for linear model, so it will fit like a straight line if you don't want it to be that curvy line. And this is what is a big benefit of ggplot, is that you can actually do both. So if you want to have, we give the data and the aesthetics, and then we want to have a scatter plot and a line chart, then you can give more than one geom. So we can have the point and the smooth. It will draw this one first and then draw this one on top. So you'll end up with like the dots and then a smooth line through it. And that makes for a pretty informative graph. So it's a nice combination if you have two numeric variables. Okay, so for the two numeric, we have geom point and geom smooth. If you have a continuous and a categorical variable, so you want to show like the difference between groups, you might want to look at a box plot. So here we have condition on the x-axis and response time on the y and geom box plot. And you'll see that this makes box plots where like the solid line is the median, and this is the first and third quartiles, and then it goes up to the max in the min values. And the dots are considered outliers, which means that they're outside of 1.5 times the interquartile range. So yeah, basically they're extreme, relatively extreme compared to the distribution of the rest of the data. But yeah, that makes box plots with geom box plot. And again, so the way that you do the axes matters only to the way that it looks. So if you want to have condition on the y and RT on the x, you can also do that, and it's just going to like flip your box plots for you. But basically, you need one grouping variable and one numeric variable for a box plot. With the same type of data, you can also do a violin plot. So this is geom underscore violin on the same data. And you can see it's like a histogram, but turned on its side and mirrored. So it just shows you the same thing, like where is the data located? Is it located in this lower range? Like you can see in the match condition, some people are slow in the match, but like a lot of people are quite a bit faster and under 500 milliseconds. Whereas like in the mismatch, there's a much smoother range that the values are all over the entire range. That's geom violin. And again, you can do two geoms at once if it's the same type of data. So having a violin plot with a box plot on top is going to work. That will show, yeah, a violin plot with a box plot on top. And here's something useful, which you can do on all types of geoms, but I'm just going to show you on this one because it makes sense, is to add an alpha. And what that means is it's going to make that geom a little bit transparent. So you can make this a little bit transparent so you can see behind it. If you wanted to make them both transparent, you could also do that. Like any, I think that works on pretty much any geom, that you can make it a little bit transparent by using this alpha. And for alpha, like a 1 is going to be the darkest and a 0 is going to be the most transparent. So you can play around with that a little bit. So you can also add information to your ggplot using colors. I mean, you can use colors to make your ggplot more beautiful, or you can also use it to map to more variables. And ggplot has two options for this, which are fill and color. And here the rule of thumb is that fill is usually used for larger spaces, like if you're filling in an entire bar, or you want to color in an entire violin plot, or this body of the whole like body here of the box plot, then you'll use fill. And color is used for smaller sections. So if you just want to color lines, or if you want to color dots, something small, then you'll use color. So let's start with color. And we can look at this box plot that we just made. The most basic thing you can do is you can color an entire geom a set color. So if you want to color the geom, the box plot geom pink, then you can set color equals pink within the geom. So then you get this very nice pink box plot. So that's, yeah, again, that's because you set the color inside the geom to a set color. And because it's a set color, it comes in quotes. So this could also be any other, like it has basic colors for pretty much most colors that you could think of. You can also give like hex codes. You can find those online. That's the way that like HTML refers to text or to color. If you Google hex code finder, you'll find like different websites that will allow you to use like a color wheel and pick an exact color, and then you'll be able to feed that into ggplot to get that exact color. There's also like a more, yeah, there's a way to also use color to bring another variable into the plot. So here we have our condition by our response times. But if you remember, this data set had condition, like matching or mismatching colloquiums, but it also had information about the animals. So we wanted to see if sentences about cats and sentences about dogs were different. So what you can do is you can actually set the color to map to another variable in the data frame. And because this has to do with mapping data from the data frame or columns from the data frame to parts of the graph, then it comes in this AES, so the aesthetics mapping. So if you want to just do a set color, it comes in the Geom. But if you want to map to something from the data frame, it always comes in AES. So if we set color equals animal in the AES and then run just like a normal box plot, then this is going to create box plots that are differentiated based on 3 variables. So based on RT condition, but also based on animal. And it's going to show that third variable by using different colors. Something that happens quite often is that if you accidentally put like a color, you just want to color it pink, for example, and you put it within this AES, then R is going to go looking for it in your data frame. It's not going to find it. So it's going to like create it and name it, like try and give it a naming. So no matter what color you give here, then it will think that that's, that you're trying to look for something in the data frame and it's just like a text string. So if you get some weird error like this, then chances are you have forgotten to put the color, the solid color that you want in the geom instead of in the mapping, because it's not a mapping. Then there's fill. So fill works pretty much the same as color. It can either go inside of the AES if you want to map it to something in the data frame, or it goes inside of your geom call if you want to give like a solid color. So for the first example, we have like a bar, because bars are colored with fill. And we had this was one of our early examples, that the x-axis is education. And we can actually map the fill to the same variable if we want. So we can just color the bars differently if we give it the same variable. So now it's representing education both on the x-axis and with color. Or we can introduce a new variable. So say we want to also take gender information into account, then we could have like education on the x-axis, but show gender with color, which would be fill, because we want to fill in the whole bar. We don't just want like a little bit of color. And if we do that, then you'll see that now this graph contains gender information. And when you have a colored bar like this is just like something specific to the geom bar. A couple other geoms is that you can dodge the bars, which just means that it creates like separate bars. That actually looks kind of strange here because we don't have every gender represented in every group. But that's something that you can do to have like bars that are next to each other. And you can also turn off the legend by having show legend false, which also doesn't make a lot of sense here because otherwise you wouldn't know what the colors were, but would probably make sense like in this one because you really don't need to reiterate what the colors mean. Anyway, those are just a couple of extra arguments that you can use for the geoms, but you'll see those if you look in the help, or if you look at some examples of ggplot graphs, you might see some additional arguments like that. And so here we used fill, right? So that's why these are filled in with big blocks of color, but we could actually also use color. And on a bar chart, color actually only refers to the lines. So here we'd have like lines that were colored based on the gender. That's not really what we're going for, but you could also mix and match these. So say we wanted the fill to be gender, but the color of the lines we want to be yellow. Then we could give fill equals gender inside the aesthetics because it needs to map that to the data frame. But we could color the lines yellow just by putting it inside of the geom bar call. That would just like outline these in yellow. Okay, so that's the basics of working with fill and color. A few other things about ggplot, then we'll give you some time to practice them. One is the labs command that you add with a plus, and that will allow you to change most labels on a ggplot. So there is like an X label, X-axis label, a Y-axis label, the label for the legend about the color, title, subtitle, even like a little caption. You can kind of see where those fall if you run this. So there's like a caption, and you can give all nice titles and yeah, kind of prepare if you're going to prepare this plot for a publication instead of just looking at it. One other thing that is nice here that I don't think I included is there's a bunch of themes for ggplot, like theme minimal, and they just give like a different look. So there's a bunch of commands where you could like customize your own look by changing the background color or changing how often these grid lines appear or all sorts of things, right? But there's also a couple of preset themes that will do a lot of that, like aesthetics, like just the look of it for you. So there's theme minimal, and there's a couple of other themes like theme void. They have different types of themes that you can either check or like RStudio will suggest some to you. So you can play around with that. And finally, the ggplot, one of the reasons that it works so well with tidyverse is that it works with the pipe. So instead of calling the data within the ggplot call, you can pipe it into the ggplot call, which will just work like exactly the same. But that also means that you can do any of these other commands in between. So say you don't want to remove like people with the elementary school education from your data set, but for whatever reason you don't want that in your ggplot, then you can temporarily filter that out by taking your data set, filtering it in this pipe sequence, and then feeding it onto your ggplot. So if we filter that education is not equal to elementary school, then we'll get a chart that, a plot that has, that part is removed. And in just a minute, I will let you do the exercises, but I want to show one last thing, which is that ggplot has a pretty flexible syntax. So we've actually showed it to you always with this AES in its own line, but there's a couple of different options for that. So actually, let me grab this plot. So we've showed it always with like as its own separate line. That's sometimes the easiest way to do it, and it's kind of a convenient way. But there's a couple of options because you can actually include the AES within the ggplot call like this, in which case that will do the same thing. So anything that's in the ggplot call will be applied to all of the geoms that come after it. Or you can put it in the geoms, in which case you have to put it in both of them. They both need to know what to map. That will also work. And then the benefit of that is that, for example, say you want to add like a color by, let's see what would make sense here. Let's go with, well, we can just go with word length again. So say we want to also make word length represented in color, but only in the dots, then we could like add an additional AES, like additional mapping to that geom in order to like add another variable in there. And you could do that with any sort of, you can add different information. So here you could see like which words were cats, and which words were about cats, and which words were about dogs. So you can do the syntax any way you want. If you're just starting out with ggplot, I would do it this way, where the AES is on its own, just kind of keeps it a little bit more clear. But if you're getting more advanced with ggplot, feel free to play around with where you put the AES and what difference that makes. Yeah, are there any questions on ggplot before we work on the exercises?
Yeah, I don't see any questions.
Okay, then let's work on the final exercises for today, and then we'll go over that.
And for these final exercises, you can choose if you want to work with the lexical decision or the phonetic data.